Hello my dear students, hope all of you are doing well. Let us learn something. Resolution of forces, solved example, right? So consider this force system. Which type of force system it is? It is coplanar concurrent force system. All forces are meeting at point A, right? Now this force is pull type or push type? Tell me. This is going away from A point and it is pull this A point, right? So this force is pull type force. This force is also pull type force. This force, it is not pull type force. It pushes point A. So it is push type force. Now this force is also pull type force. Remember one thing, the nature of forces should be same, right? So let us simplify this figure and let us convert push type force into pull type force. Now this is our reference axis. Okay, this is our reference axis, positive x-axis, right? Now starting with the first. Now this force 10 kilonewton, right? What about the angle of this 10 kilonewton with respect to x-axis? It is 60. Now next force is 5 kilonewton. What about the angle of this 5 kilonewton with respect to positive x-axis? And this angle is 90 plus 45, because if this one is 45, then this one is also 45, right? This both are 45. So this angle is 90 plus 45. Now next, for this force is push type, right? So let us convert this push type force into pull type force. Now if this angle is 15, then definitely this angle is also 15, right? Now next, for this 9 kilonewton, what about the angle with respect to positive x-axis? Angle is this, right? And that is 300, right? How it is? It is 360 minus 60. So this angle is 300, or you can also say it is 270 plus 30. So it is also 300, right? Remember, our reference axis is positive x-axis and we have marked each and every angle with respect to positive x-axis. Okay. So what we have done in this figure, we have converted this push type force into pull type force and we have marked all angle of forces with respect to positive x-axis, right? Now your job is very simple. Now this is force P1 and angle of this force P1 is 15, and we are starting from quadrant 1. So this is P1, this one is P2, this one is P3, and this force is P4, right? So angle of P1, that is 15, angle of P2, that is 10, that is 60, angle of P3, that is 5, and it is 135, and angle of P4, that is 9 kilonewton, it is 300, right? Now let us resolve all forces, right? Summation of forces in x direction, it is P1 cos theta 1 plus P2 cos theta 2 plus P3 cos theta 3 plus P4 cos theta 4. Same way for y direction, right? Now let us determine magnitude of resultant. Summation of all forces in x direction, that is sigma fx, and summation of all forces in y direction, it is sigma fy. Now what about the magnitude of resultant? Magnitude of resultant is under root of sigma fx square plus sigma fy square, right? So this is about the resultant, that is 14.15 kilonewton, and this is about the direction of resultant, that is sigma fy upon sigma fx in mod. So theta is 26.032, right? But that is with respect to positive x-axis, right? Now let us look at the position of resultant. Okay, so here the value of sigma fx, it is 12.72 kilonewton and it is positive, right? And value of sigma fy, it is 6.213, it is also positive, right? And this happens in quadrant 1. because x is also positive and y is also positive. So resultant will be in which quadrant? Resultant will be in first quadrant, right? And angle is 26 and that is with respect to positive x-axis, right? So this is about the location of resultant. So what we have done in this example, simple coplanar concurrent force system is given and we have determined magnitude, direction and position of resultant, right? Magnitude simply with resolving all forces in x and y and doing summation of that. And what about the direction? It is sigma fy upon sigma fx. And what about the position? How you will locate position? By sign of this sigma fx and sigma fy. If both are positive, then resultant lies in first quadrant. If x is negative and y is positive, resultant lies in second quadrant, and so on, right? And my dear students, if you have any doubt, any query, any questions, please mail me at structural-engineering-concepts@gmail.com and kindly comment if you have any query. And please don't forget to like, share and subscribe. Thank you for watching.